Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So in today's challenge, I will show you two methods to solve the problem, starting from O of n into k, and then we will see how to optimize that to n log k, and finally this will be our accepted solution. So definitely stay till the end of the video if you are stuck in this problem. So at first, let's try to understand the problem statement. Okay, so the maximum average pass ratio. There is a school that has classes of students and each classes will be having a final exams. You are given a 2D integer array classes where classes of I means pass of I and total of I. Okay, so it means that there are total students which is represented by total of I in the ith class, and there are this many students who you know will pass the exam. Okay, so you need to maximize the average pass ratio. Okay, so you are also given an integer extra students. There are another extra students, number of students. Okay, so they can pass any of the exams in any classes which they are assigned to. Okay, so you need to add these students into the classes distribution in such a way that they maximizes the average pass ratio across all the classes. So what is meant by pass ratio is nothing but pass ratio of a class is equal to the number of students of the class that will pass the exam divided by the total number of students, and average pass ratio is the average of all of those pass ratios. Okay, so I hope you can understand, and you need to return the maximum possible average pass ratio after assigning those brilliant extra students. Okay, so what do you need to do? What is meant by pass ratio? You see in this example 1, if you see 1 comma 2 means that out of 2 students in class 1, one will pass, and definitely the pass ratio will be 1 divided by 2 for this class, which is 0.5. Okay, and again similarly for next class, total number of students is 5 and you know 3 of them will pass, so pass ratio will be 3 by 5, which is nothing but 0.6. And here the pass ratio is again 1. Okay, the pass ratio is 1 here, and you have 2 extra students. Okay, so you need to assign 2 extra students to which of the classes. So what do you need to find here? You need to find the average pass ratio, right? So you need to find the maximum average pass ratio. So let's look at the first example, 1 comma 2 3 comma 5 2 comma 2. So if you look at this, 1 comma 2 3 comma 5 and 2 comma 2, this is given. If you were to let's say you are given k students, okay, and it is k equal to 2, but let's say you are given k equal to 0, it means that you have already assigned all the students or you are not given any students. So you need to find the pass ratio. What will be the value here? Your answer would be looking something like this. This is the pass ratio. You need to find the average pass ratio, so you sum them and find the average as you do in a normal average. Okay, so this will be your answer, but you need to increment this value. So how can you increment this value? You can definitely increment this or this. So what will happen if you add, let's say k equal to 1 now, if you add one student to some class. Okay, so let's say if you add one student to this class, it will be something like there were out of 5 students, 3 were passing. Now there will be 6 students, and the student which you added will definitely pass. So there will be 4 out of 6 students who will pass. Okay, so one will get added to both of them, so it will become 4 and 6. So now you see you got an increment in this whole ratio. If you see that what is the increment that I got in this whole ratio, that is proportional to something like this. So let's say the class which you are having is having, which you are adding this k. Okay, so let's say it's 3 comma 5, and after adding one student it got to 4 comma 6, that is 4 student will pass out of 6. So the ratio, you got an increment in ratio. This is the increment which you got. Now what is this value? This is 2 by 3, which is nothing but 0.67, and 3 by 5 means 0.6. So it means that you got an increment of which is proportional to 0.07. Okay, now this is happening if you add to the second class. This is the second class, this is the first, and this is the third. Okay, so what would have happened, what would have been the increment if you would have added to the first class? So let's see. From 1 comma 2, it would have gone to, if you add one student, it would have gone to 2 comma 3. So it means that you got an increment of 2 by 3 minus 1 by 2. which is nothing but 0.67 minus 0.5, which is an increment of 0.17. Okay, so you see, if you add, I mean, if you are adding one student to class 1, uh, then you are getting an increment of 0.17, and if you are adding to class 2, you are getting 0.07. So definitely you should add to class 1. Now if you want to see what would happen if I add to class 3, then it's very simple. 2 comma 2 will become 3 comma 3. Okay, and it will, if you subtract this, it will be 0. The increment is 0. Okay, so there is no actual increment. So the best possible case is that for the first student, if k equal to 1, for the first student you add something like this. It was 1 comma 2, you make it 2 comma 3. Okay, and these things you keep as it is. You add 3 comma 5 and 2 comma 2. Okay, so you keep them as it is, 3 comma 5 and 2 comma 2. Now you need to, let's say you have k equal to 2. So you have already assigned one student, you need to assign one more student, right? So what will you do? You again find out the same thing. You see that if you add to class 1, you will get an increment of 3 by 4 minus 2 by 3, which is nothing but 0.75 minus 0.67, which is approximately 0.08. Okay. So if you find this, this will be approximately 0.08. Now if you try to add this, you already calculated this earlier, to 4 by 6 minus 3 by 5, it's nothing but 0.07, and if you add to this, it will be 0. Okay, so these are the values. So you see, again you should add to the first class, because the increment in is getting maximum. So what you see is that if in a class there are n students who will pass out of total d students, so I will call it numerator and denominator, then the increment which you get is nothing but n plus 1 by d plus 1 divide minus n minus d. So you see, this is the increment. You see, every time this is the increment which you get. Okay, so I hope now you get an obvious brute force solution to solve the problem. And see, once you have figured out in every step which which class I should add the particular student. So you see that now you must add in first class again. So you will get you get the total student distribution to be something like 3 by 4, 3 by 5, 2 by 2. And once you get this distribution, you can easily find the average pass ratio, right? The average pass. So once you have these new distributions after redistributing the total number of students which you want to redistribute, so the final with the final distribution you can easily find out what is the average pass ratio, which is nothing but 3 by 4 plus 3 by 5 plus 2 by 2 whole divided by 3, and this will be nothing but, you see, in this also the same thing is there, 3 by 4 plus 3 by 5 plus 2 by 2 which by 3, which is nothing but 0.7833, which will be our answer. Okay, so from this the answer is quite obvious, and what you can see now is that it is a brute force solution is quite obvious now. Okay, so you have the initial classes. You need to just find out that to which class I should add my current student on. So that will be the class whichever is giving me the maximum ratio. Okay, so I hope you can understand that. So every time you can do a brute force solution. So let's say total number of students is k who we want to redistribute. So you can easily go for a loop while k minus minus, that is you want to iterate k times while redistributing k students. Every time you go through the array and you find the gain. Okay, as you know, the gain you need to find is given by this, which is nothing but the increment. Okay, so you need to find the gain, whichever now out of all the gain you find the maximum value, and you just, I mean, increment whichever whichever class is giving you the maximum gain value, you just increment that class. Okay, that numerator and denominator, that values you just increment, and at the end when you have all the classes, so you see every time for all those k you have an loop. Okay, which you can go from 1 to n. Okay, and from this 1 to n you just calculate the gain every time with this formula, and whichever is the maximum gain you just keep it in a max variable, you just calculate the max gain. Okay, and in this max gain, whichever value is giving you the maximum gain, Again you go to that index and change. Let's say 2 by 3 is giving you the maximum gain here, so you go to the index and change it to 3 by 4. Okay, so in this way you can alter the whole array. You can just alter this whole array and just calculate this result finally. Okay, so I hope the brute force solution is quite clear to you. But as you can see, this is a while loop of k and this is a n loop, so the total time complexity is k into n, so which will not suffice, actually. So you need to do something better at least. Okay, so looking at this problem at first, whenever you need to see that out of every turn, so you get an essence like in every turn, select the max gain, okay, and in every turn you see some values are getting altered also, like some value which is giving the maximum gain is changing to this. Okay, so it's changing to this. So in every turn select the maximum gain. Whenever you get these types of question, the thing which should come to your mind is priority queue, because it is a heap. Okay, if you have already studied about priority queue, I hope you will be knowing it. It is a heap, and it stores the maximum. By default it stores the top maximum value at the top. Okay, so and it is an efficient data structure because the pushing values and popping out of it in the top takes only log of complexity. Okay, log of total number of elements in the priority queue. It only takes that amount of time complexity. So I hope you can easily solve this with a priority queue. What you need to do is that at first you traverse through all the elements. Okay, you traverse through all the elements of the array, and you insert an element, you insert a pair into your priority queue. What will be the pair? It will be nothing but this gain. Okay, the gain of whole of this. So I hope you know what is the gain. It is nothing but n plus 1 by d plus 1 minus n by d. Okay, so you store the gain comma the index value. Okay, so automatically the top element of the priority queue, the top element of the priority queue will be having the one with the maximum value. Now for a pair, the maximum value is taken for the one with the first value. Okay, so the gain with the max gain, you will automatically get the index with the maximum gain. Okay, so you just do the same thing now. Okay, so you just do the same thing. You just keep a same for loop, while k minus minus. So first what you do in a single for loop, you insert all elements from I equals to 0 to n. You insert all elements. Okay, insert all elements in priority queue in max heap. Also you can known as not maximum. Okay, the maximum element is there, so you can call it a max heap also. So yeah, in priority queue you insert all elements in priority queue, then you do the same thing. Okay, but instead of a loop here, what you can do is that in every time you already getting the top element, you extract the top element of the priority queue with pq.top, you store it in a pair. Now you know that pair dot second, this pair dot second, that is the second dimension of the pair, that is the second value of the pair, is giving you the index number which is having the maximum gain. Okay, which is having the maximum gain. So you go to that index number, you increment the numerator and denominator, and again you store into the priority queue this value. Okay, so let's say you increment the priority queue. Okay, you increment the numerator and denominator, you went to the index. Okay, so you are having the classes array, you went to the ith index, you know which index to go to which is having the maximum gain, you go to the ith index, you incremented the numerator and denominator. Now you see you are having, now you can again store the gain comma this index value, because it is also possible that in the next addition the same class will get added because of the maximum value. So you just add it to the gain, again, right? So I hope this method is a little bit clear to you at least. Okay, and if you have done similar problem, then this is a very typical greedy question of priority queue. So I hope this will be clear, more clear with the coding which I do. So the thing which I will do at first is that I will go for a for loop, a simple for loop, and insert all elements into the priority queue. So okay, so I will first of all create a priority queue which is nothing but the maximum heap. It stores the maximum value at the top of the queue. Okay, so I will just store a priority queue which will store a pair of double comma integer. I hope you know why I am doing this, because double is the thing which we want to maximize the data type, and we have this priority queue, and definitely we have the length of the classes defined by n, which is nothing but classes dot size. I hope this is also very clear to you. Now what will happen is that you will go through these elements. So you will go through, let's say, all the elements in this classes, and let's say you extract the numerator and denominator. Okay, so in your calculation of class ratio, this is the total number of students. N is basically the total number of students that will pass, and T is the total number of students which is there in the class, which will form our numerator and denominator. Okay, so you just extract the numerator and denominator, and you place it in our priority queue. So you see, if you do priority queue dot push, you want to push a pair. Okay, so the pair will be nothing but n plus 1 by d plus 1 divide d plus 1 minus n by d. Okay, so this will be our pair, and the index I will also push because I need to know which index this particular numerator and denominator belongs to. So I hope this is clear to you. But wait, isn't this integer and I want to store it in the form of a double, because division will give an integer division. Okay, so I just need to convert it to double, so that is not much of a task here. Okay, so I will just convert it to double, and I hope it is very clear to you what I want to do now. And I just go through all the extra students. I just go through all those extra students, minus minus, so it means that I will iterate this many number of times. For every extra student I will choose which class I want to add to. Okay, so you see, I will take a pair at first. Okay, so I will take a pair of double comma integer p, and I will choose that I will just do priority queue dot top, because the top element will give me the one with the maximum first value. First value is nothing but double, which is nothing but the gain. So I need to select the one with the maximum gain greedily. That's our greedy algorithm here. Okay, so what you can do now is also pq.pop, since you have the element. Now the index number which you call by I, let's say index I, which you call by I, is nothing but this p dot second. I hope that is clear to you. The index number which I want to go to, which is having the maximum gain, is nothing but this p dot second. Okay, so it's quite obvious to you. And now what I can do is very simple. I can go to this class, because this is the class which I want to increment now. So let's say this is the class 1 by 2. Now I want to increment it to 2 by 3. So I go to this classes of I0 and I increment the value. And similarly again I will go to this classes of I of 1. I will increment the value. I means the, let's say this is telling me the first element. Go to the first element, and you go to the first and second element of the first element, and you increment their value. So it from 1 by 2, both of these values become 2 by 3 now. Okay, so I hope you easily get it. And yeah, so now you need to do, so you see, you went to the class, you went to the index, you incremented the class. Now you also need to push this, because this has already been popped, right? This has already been popped. Now you need to push it with the new value. So you just copy this whole thing again. You just copy this whole thing as it is again, because that's what we are doing. We are extracting the numerator and denominator again with the new values. This has been the incremented values of n and d, and I will just push that again. Okay, I will just push that again, so that that also contributes to the total gain. Okay, so whichever is the gain. So I will keep my total answer as double, and what will happen is that I will just go through all the elements in these classes. So I will just again iterate through from 0 to n, and I will just add stuffs to my answer. What will I add it is that classes of I. Okay, classes of I uh, plus equals to classes of I of 0 divided by classes of I of 1. So numerator and denominator, I simply do it, but this will be double. Of course this will be double, and in the final answer I will just return answer by n. Okay, I hope you understand this. Why? Because I need to divide this 3, so answer by n I just return it. So yeah, that is the value which I need to return, and I hope this solution will also pass. So you see, I have given the classes spelling mistake here is there. Okay, so I just change it. Wait some time before submitting. So yeah. I think this should work, and I hope you also understood the solution. There should not be much difficulty in understanding. It's quite simple what we are doing. So first we find out. So you see the runtime complexity also very good. So in order to summarize the whole solution, so you see first we find out what exactly we need to calculate, right? So you need to calculate this average pass ratio. Now for adding the remaining students, you need to find out which classes I need to add on to increment this whole ratio. So for incrementing this ratio, you can increment the numerator, and you see which element of the numerator you can increase, which that means that traversing through the whole classes, all of the classes, and finding out whichever is giving me the maximum gain, I will just increment those. But that will give me a TLE because of O of k into n solution. So instead of that, I keep a priority queue. I insert all the elements of the priority queue. Why I do that? In order to get the maximum gain in log of n time. Okay, so this the time complexity will be nothing but uh, instead of O of n into k, you will get a log of n into k. So this will be your whole time complexity, which will definitely pass. And while k minus minus, you do the same thing. You take the top element of the priority queue, you find which is the maximum gain, you go to that particular index, you increment the values, and then you just push again, you push the with the new values, with the new incremented values of n and d, you push the same thing again. Okay, so it is also taken into consideration in the next iteration. And you once you have the final answer classes, you just return this answer. You just calculate this average, weighted average, or average ratio, whichever you want. Okay, so I hope that was clear. I will not say it is much difficult, because if you know priority queue in which cases you need to use, this becomes a very easy problem, and it is not at all difficult to think. But yeah, that's all for this video, I guess. I will meet you in the next video, and I hope you have a wonderful day ahead. Thank you so much.